Hello guys, welcome back to the Syntax Byte. Once again, my name is Ryan, and in this video, we're going to continue on with the Flappy Bird game that we started last video. So just a refresher where we're at now, we have the clouds moving, we have the player movement. So when we click or tap the screen, the player jumps like we would expect to have happen in a Flappy Bird game. It kind of falls all the way to the ground. We need to create those pipes that are going to come in. And then we need to add some form of collision detection to determine when the player has hit one of the pipes and respond accordingly. So we're going to try and get all that done in this video. Now, so to start with, to add the pipes, I do have a pipe graphic. Of course, remember, I have full source code as well as all the assets that I'm using available in the link down in the description on my website, syntaxbytetutorials.com. You'll find a full write-up, everything we do in this tutorial on the videos. You'll also find the source code and written explanations there, along with the assets. But we've already loaded those in, so what we're going to go ahead and do is we got to get the pipes on the screen, then we have to animate them, and then finally we need to determine when a collision has occurred. So we got a lot to do. Let's just get started by creating the function to create a pipe. So we're going to do create pipes. This is going to be a function that's going to create a set of pipes, and we'll move it out of handle complete to, well, when we get things going, we'll actually put it on a timer. But for now, let's just put it once in handle complete. We can see if it's working how we want, and then we can kind of go from there. So what I want to do now is I want to put it, I'm just going to put it kind of under my Flappy logic here. So I'm going to do function create pipes. This is going to create a set of pipes for us. So I'm going to have variables. They're going to be top pipe and bottom pipe. I don't need to make these globals. We'll maybe need to access the pipes later, for collision detection and stuff, but I actually have a way that we're going to do that without making these globals. Now, the pipes in Flappy Bird, they kind of come at all different positions, right? So we kind of need a way to create a random position to determine where the pipes are going to be. So you could get more complex than what I'm going to show you, but what I'm going to show you is fairly basic. Our Flappy Bird is fairly easy. I've played to 100 on it. It's quite easy. It's probably easier than the original game. But you can definitely tighten up the space between the pipes. Just remember that we're doing this totally randomly, so you could have a pipe that's all the way at the top of the screen and a pipe that's all the way at the bottom, so it should be possible for users to get between those. They shouldn't just get unlucky, you know what I mean, and have to end the game that way. It should be difficult, but it shouldn't be impossible. So you can play around with it. But what we need to do is we need to pick a position somewhere on the screen that we're going to say is going to be the center of our gap. And so I'm going to call that position. And I'm going to use math.floor. So that's going to take any decimal and round it down. So even if it's like 2.9, it will round it to 2. Then I'm going to do math.random. That's going to get us a random number between 0 and 1. I'm going to multiply that by 280. That's the gap. That's the amount of screen space, minding a 100 pixel gap at the top and a 100 pixel gap at the bottom. So our screen is 480. We want to make sure that there's at least 100 pixels from the center of our pipe gap from the top of the screen and 100 pixels from the bottom. Okay? So we're going to do plus 100. So that deals with making sure that the number is at least 100. So if we drew 0 here, 0 times 280 plus 100 would be 100. And then the maximum we could ever have is 1 times 280. So that would be 280 plus 100 would be 380. So we'd have at least 100 pixels from the bottom of the screen. So that position is going to represent the middle of our gap. So what do we need to do now? Well, we need to actually initialize our top pipe and our bottom pipe. So they're very similar. I will show you there is one thing we want to do for the bottom pipe that we don't have to do for the top pipe. We'll do a new Create.js bitmap, loader get result pipe. And remember, we had our loader up here where we specified pipe.png and pipe. And once again, these assets are available on my website. We're going to set the Y position for the top pipe to be top pipe dot Y is going to be that position minus we're going to have it be minus 75. So remember, minus is up, so it's going to take this position, which I said was the center of our gap, and it's going to go up 75 from that position. Okay, so our gap is actually going to be like 150 pixels because we're moving our top pipe up 75 from there and then pushing our bottom pipe down 75 from the middle of the gap. So it's quite a large gap. And so that's how that's going to work. We'll do top pipe dot x is going to be, I'm going to set this right in the middle for now just so we can see that it's working. Normally we're going to want it to start on the very, very right side of the screen, but I'm just going to set this in the middle. We are going to set the registration point to be the middle, just on the X. We're going to set the registration point to be on the middle. We want the registration point to be like the Y registration point to be the corner, but the reason we want the X registration point in the middle is because we're going to spin the pipe. Because it's the same graphic, and in the graphic, the pipe's coming up from the bottom. So for the top pipe, we actually need to rotate it so that it's coming down from. So that's why we're going to change the registration point. So in order to get it in the middle, because I'm doing that on the X, I can do stage canvas width divided by 2, and that should set us up in the middle. I'm going to set my top pipe dot rotation, as I mentioned, is going to be 180 degrees. And I'm also going to give it a name. I'm going to give both things a name of it's going to be pipe. So later we can filter through the children of the stage and we can find all our pipes just by searching for things that have a name of pipe. Okay, so we'll know that that's a pipe by doing that. Now we can set up our bottom pipe. We will fix the registration point later. Just hold on. So I'm going to do my bottom pipe. Equals new Create.js.bitmap. Same result. So this line's effectively the same as the top pipe. Bottom pipe, I'm going to set that Y position to be equal to position plus 75. So again, this position represents the middle of our gap. I'm going to move my top pipe up 75 pixels and my bottom pipe down 75 pixels for a total gap of 150 pixels. Bottom pipe dot x is again stage dot canvas dot width divided by 2. Now, the pipe has like a sheen on it. We can look at it here. So it's got a sheen. It's actually on the right side. You'll notice in the game I decided to put it on the left side because that's just what makes more sense. But when I was making this graphic, I just ended up putting it on the right side. So we want the sheen to line up because when we rotate the pipe, the sheen's going to end up on like the opposite side of each other. So it's going to look really awkward because it's going to look like light is coming from two different directions based on where the pipe is. So we want to make sure that the sheen actually lines up. So what we need to do is we need to flip one or the other image, and in this case I'm just flipping the bottom one because I actually want the sheen to be on the left, but I didn't know that when I created the graphic. So I'd have to flip one of them anyway, so it doesn't really matter. But if you're wondering why I'm flipping the bottom one as opposed to the top one, that's why, because that's the side I decided I wanted the sheen on. So we do bottom pipe dot skew y is 180. So we're going to flip the image 180 degrees along the y-axis. So along its middle, you can imagine a line going through the pipe like from the top here and then spinning the pipe around it to show the other side, okay? Like it's effectively going to flip the image. So that's how we do that. And of course, we're going to give it that same name that I said we would give it, pipe, so we can filter for it later. Now we can deal with those registration points as I mentioned. So we'll do top pipe dot reg x equals bottom pipe dot reg x equals top pipe dot image dot width divided by 2. So that's going to be set to the exact same value. So that's why we can just do that line like that at the bottom, and then we don't have to set it separately here. So with that being said, I can go ahead and add my pipes. So we will do stage dot add child. We'll do bottom pipe, and we'll do top pipe. And we did put create pipes in our handle complete. So it should happen once when the game starts. Placing pipes in the middle of the screen, random position, they won't move or anything yet. Let's go ahead and refresh. Okay, so that's exactly what we have. You can see the sheen, as I mentioned, is matched up here. It's the same side. We've moved it over from what would be over here to here, so we flip that bottom image. We can see, our Flappy's in there. There's a gap. This one's pretty central, but we can go ahead and see that, as we refresh the screen, you can try this several times to make sure the pipes never end up off the screen. There's enough pipe there to go as far as you need, and we can see, this is working quite well. So now what we need to do is actually start the pipes over here, and then we need to go ahead and animate them across the screen. As well, we need to generate them on a timer. So how do we do that? Well, to start with, on the X position, we're going to change it from the middle of the screen to start on the very far right. So we'll do stage.canvas.width plus top pipe.image.width divided by 2. Now, remember, our X is going to be set to the middle of that pipe, so that's why we need half the pipe's width plus the total width of the screen. I'm going to go ahead and add this in here. Perfect. And so with that being done, they should start on the far right side of the screen. Now we need to make them move. So how do we do that? Well, we can go ahead and put a tween on them. Just how we've done all our movement thus far. So we're going to say create.js.tween.get top pipe.to, and we need to get it to x is going to be 0 minus top pipe.image.width. We're going to take 10 seconds to do that, so it's going to be quite a while. And when we're done, we're going to call a function which is remove pipe, top pipe, and this should have curly braces on it. And then we'll go create js.tween.get bottom pipe to x is going to be 0 minus bottom pipe.image.width. And yes, I realize that these widths should be the same, but just makes sense to match them up. Looks cleaner. 10 seconds. Call function remove pipe, bottom pipe. We'll create that function in a second. There we go. So, a couple things to take note of here. First of all, you'll notice I didn't specify any easing with tween.js. Why didn't I specify any easing with tween.js? Must have forgot it, right? Well, no. In this case, we actually want the pipes to move across the screen in a linear fashion. So, sometimes we want to ease things, makes animations look better. It just makes it look smoother. It's cool. But in the case of the pipes, we actually just want them to go across the screen, maintaining their speed the entire time. You could ease them, but I don't recall the original game doing that, and it would be a little bit awkward for players if pipes were moving at different speeds as they went across the screen. Just makes a lot more sense to do it linearly. So if you don't specify any easing with tween.js, the default is to do a linear tween. So they will go across at a constant rate. So that's one thing to note there. The other thing to note is that I have this remove pipe function that we're going to create. I'll just put it down here. And why I'm doing this is that once our pipe gets all the way across the screen, we don't want to leave it in memory. We don't want Create.js to keep having to think about it. Obviously, it won't render the pipe. I assume the library knows not to render something that's off the screen, not to attempt to render it. But we just want to remove it out of memory. Otherwise, it could be a potential slowdown for our game as players kept playing. Let's imagine they're at 100. They've got 100 pipes in memory that don't need to be there anymore. We just want to go ahead and remove them. So we'll do remove pipe, and we'll do stage.remove child pipe. Okay. Now I realize actually here you could probably just put this right here. The function is a little bit extra, but It doesn't hurt anything, and it just helps me feel organized, so I don't mind it at all. Alright, so we can go ahead and test the movement, and then what we'll do is we'll put this on a timer. So we'll go ahead and refresh it, and we see that they come across the screen. Just like that. If you want to check that it's actually being removed, what you can do is you can go to the console here, and you can actually do stage.children. It's 7, and then when they get off the screen, we should have 2 less children because we had 2 pipes that were removed, and it is now an array of 5. So we know they're properly being removed from this array, so that's good. So now we basically just need a way to generate them all the time. Now, how I want my Flappy Bird game to work is when I start here, I do want the clouds to animate. I want the users to know that the game isn't frozen, but they haven't opted to play yet. As soon as they click jump, that's when I'll bring out the first pipes, but we want to give the user a chance to get settled on the page, get ready, and once they start interacting with the game will start. So they have as long as they want to sit at the screen. It shouldn't be generating pipes yet. So what I'm going to do to achieve that is I'm going to put a variable at the top of the screen here, started, and I'm going to initialize it to false, so we know that the game hasn't started yet. Then here in create pipes, I'm going to remove create pipes from my handle complete. In my jump Flappy, I'm going to say if not started, start game. We'll create a function called start game. We'll put it here above my game over. So in start game, I'm going to say started equals true. Then I'm going to do create pipes. Then I'm going to do set timeout, or sorry, set interval. Create pipes. I'm going to do that once every 6 seconds. So we'll have multiple pipes on the screen. Now, if I didn't put this call here above, it would wait 6 seconds after I clicked, and I'd sort of just be floating in the air, kind of wondering what's going on with the game for a while. So that's why I do it once before setting the interval. So we'll do it right away when they jump. Then we'll do 6 seconds for every time after that. So we'll go ahead and save that. And so we should have, there's no collision detection yet, so of course I can go behind the pipes. And of course Flappy goes behind the pipes because he was added to the stage first. But we can see that the pipes are now generating. This is great. So this is essentially the game. Now all we need to do is just add a bit of collision detection and everything will be kind of smooth sailing from there. We need collision detection, scoring, and from there we're basically at what I showed at the beginning of the series. Okay, so how do we add collision detection? Now, this is one of the things that you have options with Create.js. It doesn't really include a lot in the way of collision detection functionality out of the box. You can use rectangle collision. You can use some pixel perfect implementations that are out there. We're going to do a mix today. You could add something probably like Box2D. I haven't done this myself, but you could probably add something like Box2D to get a full physics simulation going. That'd be a bit much for this game, but for some games it might make sense. So you have a few options. None of them are perfect, to be honest with you, but what I've decided to do for this game is we're going to just use rectangle collision on our Flappy. It's not going to be pixel perfect, but what I'm going to do is I'm going to make the rectangle a little bit smaller than Flappy, and so it's a little bit forgiving for the player, because most players would rather just grace the pipe. They know they just graced it, and they just got away with it, rather than get too close to the pipe but not quite hit it, and the game thinks it hit the pipe and ends the game. So that's kind of how I'm going to do it. So what we need to do is we actually need to put in a bit of an update function now. So when things are in handle complete at the bottom here, we've created Flappy, our pipes are going. We want to add a listener for tick, just like we added for the stage up here, but we actually want it to also do one of our own functions. So we're going to do Create.js, ticker, add event listener, tick, and we're going to implement a function called check collision. So this will happen basically every frame now. What we're going to do at the bottom here, above game over, after start game, doesn't really matter where you put it, is we're going to have our function called check collision. In check collision, we need to determine if Flappy has hit any of the pipes, and if so, we need to end the game. So to start with, we're going to basically create Flappy's hitbox. So I'm going to do var left x is going to be Flappy.x minus Flappy.regx. Remember, we put it in the middle, so I actually want to get the leftmost corner again, so I want to get back to that. So I do Flappy.x minus Flappy.regx plus 5. Why am I doing plus 5 here? Plus 5 is basically my forgiveness to the player. I know my hitbox otherwise is going to be a little bit big on Flappy. It's not a perfect rectangle here. Here, let's see if we can... Oh, we can't add like a thing that shows us where his bounds are. That kind of sucks. Okay. Zoom to fit? No. Okay. Whatever. But basically, this is not a perfect rectangle. But I'm going to try and put a rectangle around him. As a result, there's going to be, you know, areas in like kind of the corners here where it doesn't look like he hit. But if we make the rectangle too large, it's going to look like he hit. Again, most players would probably rather that, you know, the rectangle draws its line like right here and they can just grace the top of the pipe, than it draws the line like right here and they feel like they haven't even hit the pipe and the game thinks that they did. So that 5 is my forgiveness for the player. And it's going to make my hitbox just a little bit smaller than it otherwise would be. Same thing for the Y, so now we've got our upper left point, and we can work from there. I'm going to create a list of points that I want to check. So the way I'm going to do collision is it's going to be pixel perfect with points each corner of Flappy. Because if he's hit the pipe is wider than he is, so like one of the corners should actually be hitting the pipe. So I'm just going to check the corners. You could check the middle too. You could add as many points as you want. Just remember that when you're adding points, you're making things more complex and it's going to slow the game down if you add too many. So we'll do a new Create.js.point, left x, left y. So that's our very left-hand corner. We'll do Create.js.point. We'll do left x plus Flappy.image.width. And in this case, I did -10 for the forgiveness of both sides. Then I'm going to do left y. So this is my upper right-hand corner. Then I'm going to do new Create.js.point. We're going to do left x, left y plus Flappy.image.height -10. So that's our bottom left corner. And now we need to do our bottom right corner. New Create.js.point, left x plus Flappy.image.width -10, left y plus Flappy.image.height -10. And so those are all our points that we want to check. Now we want to check all of our points. So we're going to do for var I equals 0, I is less than points dot length. You guys know how to loop an array, hopefully. But we're going to go through each of these points and we're going to check if it's inside a pipe. So what I'm going to do now is I'm going to do var objects is stage.get objects under point. Points I.x, points I.y. This is going to give me a list of objects. It's always going to give me Flappy, but if it gives me any pipes, it's always going to give me Flappy. It's always going to give me the background. It might give me the clouds. But what I'm worried about is those pipes. So remember when we put a name on it before, that's how we can basically tell, okay, are we on any pipes? So we'll do if objects.filter. So we're going to filter the array for only objects that have their name be pipe. Object dot name is equal to pipe. Remember, we set that for both the bottom and the top pipe. That's going to filter that array. If that length is greater than 0, basically meaning one of Flappy's points is also hitting the pipe, then what we want to do is we want to go game over and just return from this function. Okay, and so that we know that it's working in game over rather than just logging game over, I'm going to do a create.js.tween.remove all tweens. And what this is going to do is stop the game. It's just going to freeze it. And that's what I want to happen when I hit game over. So now I want to go ahead and refresh. And what we should notice is that when Flappy hits anything, we have a bunch of errors in the log. Points is not defined. That is not good. Should be points right here. There we go. Okay, so it's happy with us. We can go ahead and play the game, and it should freeze when we hit a pipe. So we're playing the game. So far, so good. Freezes when we hit a pipe. Boom. We hit a pipe. You can see we actually had to kind of like get a little bit into the pipe. It wasn't the first hair that we hit it. We actually had to really hit the pipe because I gave the player a little bit of forgiveness. We're also not rotating the rectangle. So we're rotating the Flappy, but we're not rotating the collision rectangle. So his head's going to kind of butt up out of the collision rectangle. He's going to have a little bit more room there to just grace the pipe when his head's moved up a little bit than he would otherwise have. So that's all well and good. I mean, it's not perfect, but it's good enough for our case. Some players may get lucky, and you know that's fine. That's kind of part of the fun of the game. So this continues, which is kind of weird. But yeah, so for our cases, this kind of works fine. It's not perfect. I know there's an issue where because he's rotated up, yeah, he kind of hits the thing there. It's pretty weird, the way it's operating at the moment, but that's okay. So the game over doesn't work quite right, but we'll get to that in the future. Before I go, I just want to show you guys something. If you are having trouble with the collision, or if you want to make adjustments, there's a way you can kind of draw the collision box out so that you can see what's going on. Because right now, you can't really tell where his collision box is, and that kind of makes it difficult to make adjustments or even really understand if you're having an issue with collision, why that is. So, what we can do is basically draw a box around. So what I'm going to do is I'm going to create a global. I'm going to call it var polygon at the top here. I'm also going to adjust from stage.gl to simply stage so we don't have to worry about caching it. In our handle complete, I'm going to add it here. I'm going to go stage dot add child. It's going to be polygon. You can call it like hitbox or something. What I'm going to do in my check collision, before I check my collision, is I'm going to say polygon.graphics.clear.begin stroke black. Then I'm going to do polygon.graphics.move to, and basically we're going to draw between these points. We're going to start with that upper left hand corner, points 0.x, points 0.y. Then we're going to do a line 2. We're going to do what is going to be that upper, that bottom left hand corner. We're going to do points 2.x, points 2.y. Then we're going to do a line 2. We're going to do points 3.x, so that's that final one here. That's going to be our bottom right hand corner, points 3.y. Then we're going to swing it back around to our upper right hand corner, which is going to be points 1. So dot line Here, let me drop this down so we can actually see what we're doing. Line 2 points 1 dot x points 1 dot y. Then what we're going to do is we're going to take it to back to that original upper left hand corner. So we're going to do line 2 points 0 dot x points 0 dot y. Save it, and we should actually be able to see our collision rectangle. Polygon is undefined. Oh, sorry, my bad. We have to actually create it as a shape here. So we'll do polygon equals new Create.js dot shape. Undefined, has no properties, 125. Okay, so there we go. Firefox is just being weird. There's nothing wrong with my code. But basically you can see this is drawing the collision box. So each of these points is actually where we'll be checking for collisions. So you can see how the points might actually be, a little bit depending on where he is. Sometimes the points are, a little bit off depending on where he is with that rotation. So you can make it more or less forgiving. You can move the points around. You don't even have to make it a perfect rectangle. You could add 6 points. You could have a total polygon going. Maybe you want to check kind of by his butt here. You want to check. Yeah, see, we can see it hit, but he just kind of snagged it up there, actually. But it was this point that hit the pipe that actually triggered that collision issue. So it's not perfect, but it's a relatively simple solution for this game. You can explore other solutions. It is pixel perfect in terms of the pipes. So I'll just show that by if we go up here. You can see we actually have to hit this side of the pipe. It doesn't, it's not like there's a line kind of floating out here by this area. But if you did snag that area, you would get hit too. So it's rectangle. It's actually just 4-point collision for the bird, but it's pixel perfect for the pipes. So it's kind of what I came up with. It works okay for the game. Honestly, the collision detection is probably as good as the original Flappy Bird. But that's how you can view kind of where the collision rectangle is, where your points are. And then that way so you can actually make adjustments as you see fit. Anyway, guys, I will see you in the next video where we will actually implement scoring and kind of fix up some of the game over behaviors, and then we'll be essentially almost done this game. Link in the description to the written tutorial as well as the files and source code, and I will see you in the next video. Like, comment, subscribe if this is helping you out.